In this video, I'm going to talk about one of the common techniques for improving your MATLAB code performance. Let's use the example in section 9.4. We have a symbolic function f. It's a function of two arguments, r and s. Here, we want to find the roots of the polynomial function for different value of s. Here we are interested in the value of s from 0.09 to 0.01. Then we use the for loop to assign s to different values. Then we use MATLAB command solve to find the roots of the polynomial function. Then we convert the symbolic variable r to c. Then we plot the functions. But this is inefficient. Here we will talk about one technique to improve the performance of this code, that is vectorization. The first step in improving performance is often measure the performance. This is usually done by timing the code. This gives you something to compare against after you optimize your code. To measure the timing of MATLAB code, you can use the tick-tock function. The tick commands to start the timer, and the tock commands stop timer and represent the result in seconds. Because tick and tock measure clock time, your computer background task can cause timing measurement to vary slightly. So therefore, you want to close all unrelated apps in your computer. The tick-tock may give you different results for consecutive timing of the same code. So often it's a good idea to make several timings, like here, then take an average of them. So let's first run this code and see the time for executing these several commands. So here it shows to execute this MATLAB code in for loop. On average, it takes about 2.4323 seconds. You could do this with a for loop. However, MATLAB is an array-based language. You can often get improved performance by using MATLAB functions that are specially designed to work with arrays. The process of revising loop-based code to use array operations is called vectorization. It is one of the common techniques for improving code performance. The code often runs faster and more concise and looks more like math equations. You could look for opportunity to vectorize your code and consult MATLAB documents for possible solutions. Here to vectorize the code to serve the same purpose. So we can first to find the variables we want. So that is a variable from 0.09 until 0.01. Then we can plot actually the vector function for different value between 0.01, 0.09 until 0.01. Then to find the roots, we can use the array function handle. So that's array function handle. Then we consider this is a function of S. Then the S is a vector. Then we find the roots for each entry of the vector. So here we define array function. So here is an anonymous function. So that's a function of S. Then we assign S with different value from the var function. Okay, so this is the array function. Then we find gamma by convert the symbolic variable to numerical variable. For fair comparison, first let me clear the workspace. Now let's find the average time to use the vectorization technique. Again, we run the same code 3 times and take an average. Here you can compare the different code. Here we use about 2 seconds and 2.3744 seconds. Using the for loop, it took 2.4323 seconds. We can see that by using the vectorization technique, we do improve the code performance a bit. For fair comparison, first, then let's run this code using vectorization first, then using the for loop. Then first, let me clear all outputs. This time, let's first run the code using vectorization. This time, it took about 1.6080 seconds. For the for loop, it takes about 1.5211 seconds. This time, the for loop is a little bit better. Then let's run it again. Then the performance is 1.4277 seconds for the vectorization technique. For the for loop, is 1.4822 seconds. We see the result using vectorization is a little better. Let's do one more time. We still get 1.4280 seconds. Here you have 1.4681 seconds. We see the MATLAB code using vectorization is a little better. One more time. One 1.4034 seconds. One 1.4807 seconds. It's kind of like the time to run a for loop is around 1.48 seconds. Then using the vectorization is about 1.40 seconds. Therefore, we can make the conclusion that the MATLAB code using the vectorization is a little better than the one using the for loop. Now let me clear the output, then we can remove all of them. Just keep our original code. Also, you can see that the MATLAB code using vectorization, it looks more concise. Here you have 1, 2, 3, 4, 5, 6, 7 lines of code. And for loop, you need to create a assigned space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You need 11 lines of code. Here is only 7 lines of code. The MATLAB code looks more concise and it runs with less time.